Okay, hey everybody, Mr. Mac here. I'm doing a quick video here to help you with your homework. On this section, we're doing arc length using radians, and we did this problem today in class, example 4. I think you guys got up through 4. I want to jump in on 5 here, and I think I'm just going to do 5 unless I do this quickly and I change my mind. But let's take a look at this. The centers of two belt pulleys with radii of 3 inches and 6 inches respectively are 13 inches apart. Find the total length L of the belt around the pulleys. Okay, so we have a pulley that's 3 inches and 6 inches. And so that means the radii is that, the radius of each. And I'll label that in a second. I'll label the radiuses in a second, the radii. But they're 13 inches apart, so I will do that now. Actually, so let's call this one, and I'll call this center A and this center B, maybe. So we have a frame of reference. And I'm going to draw a segment between the two. And this segment is 13 inches apart. Okay, it said right there, the centers are 13 inches apart. Now a belt goes around these pulleys, so like we would see on an engine, a car engine. And let's do this in red too. So it's going to go from off of this belt wheel, connect to here. It's going to wrap all the way around this pulley. Oh, it's terrible. Oh my goodness. So hard to do. All right, maybe this tool is easier. Yeah, okay. That's not bad. And then connects to that pulley, and then we'll continue around. I almost had it. Well, it's going to take me, half the time in this video just drawing these arcs. Okay, so there it is. We're looking for L, the length of L. Okay, so you see we have two straightaway sections right here, and these are, notice this is a symmetrical figure, so these two straightaway sections are going to be congruent. And then I have this arc, and I have this arc right here. So we have two sides plus a small arc plus a large arc. How about that? Just to set up the problem. Just give it some structure here. Okay, so let's draw these radii. Now, this segment is touching the circle right at one point. If we extended this, right? If we extended this line, I don't know, maybe look like that, and it would just touch that circle at one point and that circle at one point, right? But I'm not interested in the whole line, I'm just interested in the segment. But still, at this point here and at that point here, the line touches the circle before it turns into an arc. Same down here, here, and here. And so I'm going to connect my radius from the center to that point and to that point, like that. And then here and there. So this length here is 6 inches, and this one is 3 inches. So let's see, A, B, so maybe I got C, that's point C to D, and E to F. So I've got two CDs, two CD lengths, which is also, e to f here, plus arc FC and arc DE. Okay, that's my large arc. So, and we know our arc length equation here is S equals R theta, right? So the radius of these arcs we have. So what do we not have? We don't have this angle. I don't know this angle here, theta, maybe theta 1, and I don't know this angle here. Sorry, I did the wrong angle on this one. Let's back up. I need this angle is theta 1. And then this angle, we can call that theta 2. Okay, so what do we do? Next step, we want to think, how can I start solving for these side lengths and these angles? Now, if we see here, there's a right triangle. If I go from 3 inches, the center here, off of my 3-inch radius, from A, and I make a parallel line, and I go all the way to the radius of the larger pulley, we'll see, we know this radius right here is perpendicular to this side, because that's what a tangent does. Same with this. So we know that we have a rectangle here. So I'm going to shade this rectangle in, okay? And what do we know about rectangles? Well, I know this segment here is congruent to this one, so I know that's 3 inches. That must mean that this segment is 3 inches, so that's 3 inches right here. And then these segments here are congruent. So do you see I have a right triangle right here? And maybe make this yellow. This yellow right triangle, I know the hypotenuse is 13 from A to B, and I know this leg is 3. So I can use Pythagorean theorem here. So I've got A squared plus B squared equals C squared. Let's call this leg A. So I got 3 squared plus, I don't know B. That's this blue segment right here, equals 13 squared. That's the hypotenuse right here from A to B. And so we're just going to solve this. And how about, we'll see how it works out. Well, 13 squared is 169. So 169 minus 9. We're taking the square root of 160. And I don't have that written down, so I'll do it. Square root of 160. 12.65. So let's just go 12.6, 12.65, 12.7 inches. That is this length here, 12.7. So actually I have now the length from C to D. So I know this first part. L is 2 times 12.7 plus. Now, I still need to get my thetas. Let's see here. How about I do the same for this triangle down here? Now, I know this angle is 90. I know this angle is 90. These two angles are congruent. So how about this? A complete circle, right, is 360, but we're thinking in terms now of radians. So that really is 2 pi. one complete circle is 2 pi. So I know if this is 90 and this is 90, that's 180. So that's already a pi worth, right? 180 is equivalent to pi. We know 180 degrees equals pi. So I just need to find these two angles, or just one because they're both the same. And then I can find theta 1 by just subtracting these angles from 2 pi. So I have a right triangle. Let's put, maybe I'll just use a variable x here. X is my angle that I'm looking for. I know the opposite leg is 3, and I know the hypotenuse is 13. Opposite and hypotenuse. That is sine. So if we do sine of x, just remember it's opposite over hypotenuse, right? Opposite leg over hypotenuse. Sine of x equals 3 over 13. And now I'm going to take the inverse sine and I'm in radians here, so I'm going to make sure I check my mode. Yes, I'm in radians. Inverse sine of 3 divided by 13 should be a small angle, 0.23. This is radians now. 0.23 radians. Now if I multiply that by 180 over pi, it'll convert it to degrees, but I'm happy with 0.23. So this is 0.23, and this is 0.23. So now what's theta going to be? Theta 1. Theta 1 is going to be, we're going to take, well, I guess I could do it this way. Maybe this is easier. I know that theta 1 plus pi, because these two 90 degrees make 180, and 180 is pi, plus 0.23 plus 0.23. These two little angles all have to add up to 2 pi. Remember, 2 pi is a complete circle, right? So now, if I do pi plus 0.23 plus 0.23, that's 3.601. So let's just go 3.6 equals 2 pi. And then I'm going to subtract 3.6 from 2 pi. 2 pi minus that answer right there. 2.68 radians. So this angle is 2.68 radians. If I multiply that times 180 divided by pi, that's 153.6 degrees. Just to keep it in perspective, that's about 153.6 degrees. But our theta in radians is 2.68. So now, my small arc is going to be r theta, right? R. So right here, I know r times theta is my S equation, right? Well, I know my r. It's 3. Theta is 2.68 plus, okay, now my radius for the larger arc is 6. Okay, now look at this, guys. This angle here is the same as this angle right here. This is also theta 1, this inside angle. And I mean, if we know these 0.23, we know there's 180 degrees in a triangle, right? 180 converts to pi. So if we actually subtracted and found these angles right here, we would find that it's 2.68. Okay, these angles are I mean, these lines are parallel. These segments right here are parallel. This would be the same angle. So therefore, theta 2, we know, adds up to theta 1 to be 2 pi. That's a complete circle. So if theta 1 is 2.68, we can just solve for theta 2 by subtracting 2.68 from 2 pi. So 2 pi, doing it on my calculator now, subtract 2.68, I get 3.6. Well, wait a second. Where did we see that before? We saw it right here. Because that ended up being these four angles added together, right? Do you see where we already saw that before? Okay, so that is our theta 2. We already know our radius is 6. Now I've got everything. I can find the length of this rope. I do 2 times 2.17, 12.17, 2 times 12.7 plus 3 times 2.68 plus 6 times 3.6. Okay, so I'm just double checking what I typed in. 3, 2.68, 6, 3.6. And I get 55.04. So I'm going to say about 55. 55. And what are we in? Inches. And that is the length of the rope that goes around. That's the length of the belt that goes around these pulleys. I definitely think this is a more challenging problem than some of the other ones that we got. And so take a crack at these next ones right here. Just for a little bit of help here, you know that you can where can you make your right triangles? Think about that. That this might help in finding these lengths here. And know that this pulley comes in directly at the top and goes out directly to the side, and think about what that angle is that we're using for this arc length right there. Okay, I think I just showed it to you. All right, guys, I'm going to leave it there, and we'll continue working with this tomorrow. I hope that helps. I'll see you all later.